It's really easy to look at the absolute cutting edge of technology and just assume it's this, I don't know, this sleek, flawless, perfectly orchestrated symphony of
Oh,
progress.
for sure. We have this image of gleaming machines just doing everything with absolute perfection.
Right, exactly. But then, you actually look at the current state of robotics and you realize that a machine packing, like more computational power than the Apollo missions, can still get completely defeated by a slightly uneven rug.
Yeah, it's basically the great irony of modern engineering right now.
It really is.
I mean, we've given them these absolutely brilliant electronic brains, but their physical bodies often lack the coordination to, say, successfully open a standard door handle without falling backward.
To falling completely flat on their backs. Well, welcome to the deep dive. To you, the learner. We are so, so glad you're here with us today.
Glad to be here.
So our mission for this deep dive is to unpack something incredibly fascinating. We've got this stack of notes, specifically an AI News Digest from August 4th, 2026. And it summarizes a really deeply insightful piece from Technology Review. The title is, Trump's AI Protectionism Has Come for Robotics.
It's a heavy hitter of a piece.
Yeah, it really is. And our goal today is to understand how massive, high-level macroeconomic political maneuvering is suddenly colliding head-on with the, well, literal nuts and bolts of the robotics industry.
The physical hardware.
Exactly. And really quickly, for you, the learner, I want to emphasize right up front that our aim today isn't to debate the politics of this, or endorse any viewpoints on either side.
Absolutely not. We're strictly looking at the mechanics here.
Right, purely the mechanics. We want to know how pulling these massive geopolitical levers actually impacts the technology of tomorrow. So we're viewing former President Donald Trump's policy shifts strictly as strategic maneuvers.
Which is really a critical lens to use, because if you view this purely through, like, a partisan filter, you totally miss the profound economic and developmental shifts that are happening right under the surface.
Yeah, you get blinded by the noise.
Exactly. We are looking at the intersection of silicon and policy,
Right.
which, historically speaking, is where the biggest global transformations happen.
Right. So getting back to that contrast we started with, the Technology Review piece explicitly notes that humanoid robotics still struggle to perform basic tasks with, like, the finesse of a toddler.
They do. They really do.
They're prone to these notorious mishaps. Yet, despite moving like clumsy toddlers, this technology is now the absolute focus of intense national security and economic policy.
Yeah.
So why is the government putting a protective shield around something that can, barely walk up a flight of stairs?
Well, what's fascinating here is the massive disconnect between what goes viral on social media and what is actually happening on the ground in the real economy.
Okay, what do you mean?
Like, yes, the videos of robots tumbling over or, failing to grasp an apple, they're funny. They highlight that toddler phase of physical finesse we were just talking about.
Right, the fail compilations.
Exactly. But behind the scenes, away from those viral fail videos, the industry is undeniably on a massive, massive upward trajectory. Yeah. The actual economic value isn't in backflips, it's in predictability.
Okay, yeah. And the source actually notes they're becoming way more prevalent in manufacturing and service roles.
Huge integration happening quietly.
Yeah. And I was trying to visualize what that actually looks like on a factory floor, considering the clumsiness. So tell me if this analogy tracks for you.
Lay on me.
Right now, bringing a current humanoid robot into a facility is basically like hiring a brilliant but clumsy intern.
A brilliant but clumsy intern. Yeah, I like where this is going.
Right, think about it. You hire this intern, and their brain is just incredible. They have a 200 IQ, they can process massive data sets in milliseconds, they, natively understand the company's entire logistical network.
Total prodigy.
Right, but physically, they are a total disaster. They drop the coffee in the break room, they trip over the printer cable, they accidentally knock over the whiteboard during a meeting.
Total chaos.
Yeah, but as the boss, you don't fire them.
No, you don't. Because you recognize that the physical clumsiness is just it's a temporary mechanical issue.
Right.
While the underlying intelligence is a foundational asset for the future of your company.
Exactly. So you're essentially buying the intellectual property early. You tolerate the broken coffee bugs today because you know that, say, in 5 years, this intern is going to be running the entire logistics operation.
Right. And you want to keep them in-house.
Yes. You want to make sure they're loyal to your company, not your competitor.
That analogy perfectly captures the strategic mindset driving these policies. I mean, governments aren't looking at the robot that falls over today. They're looking at the foundational economic engine of tomorrow.
The long game.
Always the long game.
Hmm.
If a country controls the manufacturing and the intellectual property of the machines that will eventually build, well, everything else, they secure an unprecedented economic advantage.
Wow. Yeah, that makes sense.
The toddler phase is just a temporary hurdle. The real focus is on the environment in which these robots currently excel,
Mm.
which is highly structured, repetitive tasks in controlled factory settings.
Right, where you can control the variables.
Exactly. They might not have the dexterity to perform open-heart surgery quite yet, but they can move identical heavy boxes for 24 hours straight without requiring a break.
Hmm.
Or a pension, for that matter.
Okay, let's unpack this. Because if governments recognize just how valuable this brilliant intern is, the immediate reaction is to protect it.
Naturally.
And that brings us to the core of the source material, the shift toward what the article calls AI protectionism.
Right.
The article details that under Trump's direction, there's a significant policy shift built on two main pillars.
Yeah, two big ones.
First, prioritizing the domestic development and production of robotics technologies.
Yeah.
And second, reducing dependency on foreign innovations to, secure America's technological edge.
The walled garden approach.
Exactly. But this is where I get a little tripped up, and I want to push back on the mechanics of this strategy just a bit.
Please do. Where do you see the friction?
Well, historically, the entire field of artificial intelligence, which is the brain of these robots, it's thrived on being open.
Very true. Open borders, basically.
Right. It's built on open source code, global supply chains, international researchers sharing papers at massive conferences. It's an inherently borderless endeavor.
It is.
So how do you practically build a walled garden around a technology that fundamentally exists on global collaboration? I mean, even if you build the physical robot in America, the software driving it can still be open source, right?
Technically, yes.
So if an adversary downloads the exact same open source model and just slaps it into their own domestic robot, hasn't the walled garden failed anyway?
It's a fair point.
Isn't trying to lock down AI and robotics like trying to catch water with a net?
That is the multi-trillion-dollar question right there. And the answer lies in understanding the concept of technological sovereignty, but specifically as it transitions from the digital world to the physical world.
Okay, say more about that.
You're pointing out software sovereignty, which, exactly as you noted, is incredibly difficult to enforce.
Because it's just code.
Right. Pure code can be downloaded, emailed, and shared across the globe in seconds. You really cannot easily put tariff on an algorithm that's uploaded to a public repository.
Yeah, that makes sense.
But robotics introduces a severe physical bottleneck.
Oh, the actual body of the machine.
Precisely. Securing the technological edge isn't just about the software anymore. You can have the most advanced AI brain on the planet, but if you rely on a foreign adversary to manufacture the physical components,
You're stuck.
you don't actually have sovereignty over that technology. Let's look at the anatomy of a modern robot for a second.
Uh-huh.
The AI model might be trained in some server farm in Silicon Valley, right?
Right.
But the LiDAR sensors that allow it to see, those might be precision engineered in Germany.
Oh, wow.
The localized battery cells giving it power, those are mostly manufactured in China. The specialized joint actuators, the little motors that give it movement, often imported from Japan.
And just to clarify for the learner really quick, when we talk about things like LiDAR and the robot's ability to see, we are getting into something called spatial AI, right?
Exactly. Spatial AI.
Meaning the robot's ability to actually understand 3D space, knowing a wall is a solid object to avoid rather than just processing text on a screen like a standard chatbot does.
That is a crucial distinction. Large language models process text, sure, but spatial AI requires a constant real-time feed of physical data to navigate the real world.
And that data requires hardware.
Incredibly sophisticated hardware. You cannot download a robotic arm.
Right.
It requires rare earth metals, massive manufacturing infrastructure, and a highly, highly specialized physical supply chain. Untangling that specific global web is monumental.
So the walled garden being proposed here isn't necessarily about stopping ideas from crossing borders. It's about ensuring that the physical capacity to bring those ideas into reality exists entirely within your own borders.
Bingo.
The blueprint is totally useless if you don't have the raw materials and domestic factories to assemble it.
Exactly. The policy is attempting to force the physical infrastructure to catch up to the digital ambitions, and crucially, to do so domestically.
Okay, I see.
It's basically about saying, If global supply chains break down tomorrow due to a pandemic or some geopolitical conflict, can we still build the machines that run our factories?
Right. It's a resilience thing.
Yeah, that physical reality is what makes protectionism possible in robotics, whereas it was just much, much harder in pure software AI.
Because you can't stop a download, but you can stop a shipping container.
Exactly. You can restrict the export of specialized chips, you can subsidize domestic rare earth mining,
Okay.
and you could definitely place heavy tariffs on imported robotic actuators.
Here's where it gets really interesting, though, because when you force that kind of massive shift, I mean, telling an entire globalized industry to suddenly pull its operations, its talent, and its supply chains behind national borders,
Yeah, people are going to talk.
the people actually building these robots are going to have strong opinions.
Very strong.
And our source material outlines a deeply divided reaction within the industry itself.
The policies have definitely acted as a massive polarizing force. The industry response is far from monolithic, largely because, well, the financial implications are staggering.
Let's examine the praise first.
Okay.
The source notes that some industry leaders are actively lauding the initiative because it essentially forces massive investment into local talent and domestic innovation.
Right.
Like, if you can't rely on cheap foreign manufacturing or imported components, you have to spend money training American engineers and building American factories.
It essentially creates a captive market for domestic skills. It forces venture capital and corporate investment that might have gone overseas to be deployed at home instead. For a domestic mechanical engineer or, say, an American battery startup, this policy is a massive windfall.
Because it cuts out the competition.
Right. It artificially creates demand for their expertise by cutting out that foreign competition.
But then you have the other side of the coin.
The concerns.
Right. Other voices in the industry are sounding the alarm over rising global trade tensions. They really fear that closing the doors will stifle the international collaboration that got us to this point in the first place.
It's a valid fear.
It is. And when I try to visualize the real-world impact of this closed-door approach, it feels like, well, it's like studying for a test.
Oh, a test. How so?
Okay, imagine you're studying for this massive, critical final exam. But the policy is basically telling American engineers they can no longer share notes with the rest of the class.
Ah, I see.
They have to study completely alone in their room to guarantee they get the best grade without anyone else copying their work.
Total isolation.
Right. But what if they miss out on a key insight someone else discovered? What if the kid in the next row figured out a shortcut for the math problem, but you never learn it because you locked the door?
Right. You're secure, but you're blind to outside breakers.
Exactly. You might still pass the test, but it's going to take you way longer to study, and you might not get the absolute highest score possible because you isolated yourself.
If we connect this to the bigger picture, that analogy perfectly encapsulates the ultimate gamble of protectionist policy in technology.
A gamble, yeah.
It highlights the extreme tension between short-term friction and the intended long-term gain, because the immediate friction is severe.
Yeah, I'd imagine.
We're talking about disrupted supply chains, rising costs of raw materials, and the very real possibility of missing out on international breakthroughs, just like your study notes analogy.
Right.
When you cut off the flow of global ideas and materials, innovation will inevitably slow down in the short term. The development cycles get much harder.
And way more expensive.
Right. Drastically. Because building a local fabrication plant for, advanced sensors costs billions of dollars and takes years to stand up.
Which means the consumer ultimately pays more, at least initially, because the company has to recoup the cost of building those domestic factories instead of just importing the cheaper parts.
Exactly. That is the short-term pain. But the intended long-term gain, the massive bet that these policymakers are making, is that this pressure cooker environment will eventually forge a deeply resilient, entirely self-sufficient domestic talent pool.
A self-sustaining ecosystem.
Right, and a manufacturing base to match. So the question the technology review piece ultimately poses is basically the defining query of this era.
Which is?
Will this closed-door approach act as a crucible that bolsters American innovation to new independent heights? Or will it simply stifle the collaborative spirit that historically drives the fastest technological advancement?
It's just a massive roll of the dice.
Huge.
Because if you isolate yourself to get stronger, you better hope you actually have all the necessary ingredients inside the room with you.
Exactly.
And as we discussed with the LIDAR, the batteries, and the actuators, No single nation has historically held a monopoly on all of those disciplines simultaneously.
Never.
You're asking domestic engineers to suddenly become world leaders in material science, battery chemistry, spatial AI, and mechanical engineering all at once.
Which is an incredibly tall order,
Yeah.
even for an economy with massive resources.
So, what does this all mean? We have covered high-level geopolitical strategy, technological sovereignty, and, the complexities of global supply chains.
A lot of macro stuff.
A lot of macro stuff. But I want to bring this right down to the ground level for you, the learner. Like, why should you care about where the metallic joints of a clumsy humanoid robot are manufactured?
It can definitely feel very abstract until those supply chains start affecting your local economy.
And it matters because this isn't just about robots. It's about the entire ecosystem of tomorrow.
Everything connects.
Everything. Whether you're working in the tech sector, managing an investment portfolio, or honestly just planning to buy the next generation of smart electronics, the way these machines are built, and crucially, where they are built, is going to fundamentally shift based on these exact trade tensions.
Oh, absolutely.
If the industry is forced to prioritize domestic production, you might see massive booms in manufacturing jobs in certain regions, completely changing the landscape of local economies.
We would see a total renaissance in physical engineering disciplines.
Yeah, exactly. You would also likely see the cost of consumer robotics temporarily spike as those supply chains are painfully rerouted.
The short-term pain we mentioned.
Right. And the skills that are valuable in the job market will shift. You might see a massive premium placed on domestic mechanical engineering and local battery chemistry expertise rather than just purely software development.
Hardware is making a comeback.
Big time.
Yeah.
The high-level policy we are discussing today is going to dictate the reality of the ground-level economy for the next decade.
This raises an important question, though, and it's something I want to leave you, the learner, to ponder on your own, building on that idea of stifled collaboration and fractured supply chains.
Oh, I love a good hypothetical. Lay it on us.
Well, if this trend continues, if global cooperation truly fractures and major global powers all retreat into their own walled gardens to build their own isolated robotics ecosystems,
Okay.
what happens when those systems actually need to interact?
Oh, wow.
Will we end up in a world where a robot built in one country literally cannot communicate with or operate on the digital and physical infrastructure of another?
That is wild. Like an American service robot gets shipped to a facility in Europe, but it can't interface with the local smart grid.
Right.
Or its spatial mapping AI is fundamentally incompatible with the layout protocols of a foreign factory just because they were developed in total isolation from one another.
Exactly. We could be looking at the technological equivalent of the Tower of Babel.
The Tower of Babel.
Mm.
Man.
Instead of a unified global standard for robotics, much like how the internet operates on unified protocols today,
Right, TCP/IP and all that.
we might create fractured regional species of machines that are entirely incompatible.
Just completely walled off.
The very protectionism meant to secure the technology could ultimately limit its global utility and scale. We might be designing robots that are as structurally divided as the geopolitical landscapes that birthed them.
That is a staggering thought to end on. It really highlights how these high-level policy decisions don't just change, like who makes the money.
No, it's deeper than that.
They fundamentally alter the shape, function, and future interoperability of the technology itself.
Absolutely.
We started this deep dive by looking at a machine that still stumbles around with the finesse of a toddler, dropping its coffee and tripping over its own feet.
The clumsy intern.
The clumsy intern. But now we see that this clumsy intern is carrying the weight of massive geopolitical strategies, trade wars, and the entire future of the global manufacturing economy on its slightly wobbly shoulders.
It's a really heavy burden for a machine that's still mastering the art of walking on carpet.
It really is. Well, learner, we hope this deep dive helped clear away some of the jargon and showed you the incredible mechanics at play behind all these headlines.
It's a lot to process, but it's crucial stuff.
It is. We wanted to give you the tools to understand how shifting policy levers directly impact the physical creation of tomorrow's technology. Because as always, the world of policy and AI is moving at breakneck speed, and they're going to keep colliding in really unexpected ways.
The landscape will certainly look very different even a year from now.
Without a doubt. Thank you so much for exploring this with us. Keep questioning the headlines, keep looking for the underlying mechanics of how things are actually built, and until next time, stay curious.